Hey guys, this video is going to show you how to write an equation that you are given in standard form and to change it to graphing form, but this time there is going to be a coefficient with the x squared. So you might see something like this, okay, and there's going to be a number in front of the x squared. So I'm going to show you what you can do if you see something like this. Alright, so yesterday we took notes on what graphing form should look like. It's always in this form. The problems that we did yesterday, they ended up looking like this at the end. Okay, so they ended up looking like this. The only thing that's a little bit different is there was no number outside of here, or no coefficient. Today, we're going to get a number outside of there, so we might end up looking like this. Okay, so we're going to end up with a number outside of here, and then the rest of the graphing form, just like we did yesterday. All right, so first thing that you're going to do, just like yesterday, is you're going to change the y to a 0, and you are going to try to get the c term, remember that's this term back here, to the other side. It just makes it a little bit easier. So I'm going to subtract 5 from both sides. So I end up with negative 5 equals 2x squared plus 8x. Okay, from here, this is what you want to do next. So I do not want this 2 in front of the x squared. It makes it much easier if it's just x squared, because we're going to have to write this in perfect square form. So what you can do is we're just going to keep that negative 5 there. I'm going to divide a 2 out of here. Okay, I'm also going to divide a 2 out of here. Now I'm not really dividing it out, I'm just rewriting it using the distributive property. So I'm going to make big parentheses back here. I'm going to say, well, if I divide a 2 out of both of these things, it's 2 times x squared plus 4x. So again, I did not really change this side at all. I just wrote it in another way. Okay, so this right here is the same exact thing as this right here. If I would times it out, it would just equal it. So all I did was rewrite it in a different way. Okay, my next step is I'm going to try to complete the square here. So what you're going to do is you're going to come to this middle term, and I'm going to do half of 4. Half of 4 is 2, and then 2 squared is 4. So I want this number back here to be 4. So I'm going to say, well, I want it to be plus 4. So again, I'm just completing the square. Now, if I add 4 into this side, I have to do the same thing to this side, but I have to be careful. This wasn't really just adding 4. This was actually adding 2 times 4, which is 8. So I really added 8 to that side. So I need to add 8 to this side as well. So I end up with 3 equals 2 parentheses x squared plus 4x plus 4. Okay, now the point of this is to get this, remember, in perfect square form, which this is a perfect square. So if I write it again, I get 3 equals 2 parentheses. This should be a perfect square. Remember, it's x, and then remember, it's half that middle term, so x plus 2 squared. Now, this is almost in graphing form or vertex form. I just need to move the 3 to the other side. So my final answer is y equals 2 parentheses x plus 2 squared minus 3. Okay, so this right here is my vertex form. Now, I should be able to list the vertex. Okay, we did this the other day. So my vertex is going to be, remember, it's the opposite of what's in there, so negative 2, comma, and then this other term back here, negative 3. So there's my vertex. So again, here is graphing form, and then there is my vertex. Quick refresher too, if I ask you what the y-intercept is, remember, you go back to the original equation, it would be 5. So the y-intercept is 0, 5, just as a quick refresher. You could also find the x-intercepts. Again, remember, we said you would go back to perfect square form, which was right here, and then you could square root both sides, go from there to find the x-intercepts, which we'll do more of when I'm back. So let's try another one. So we have our starting equation up there. So again, I'm just going to fill this in with a 0. My first step is I want to move the c term, so that last term, over to the other side. So I'm going to subtract 1. So I get negative 1 equals 3x squared minus 6x. Okay, now I want to try to write this in perfect square form. Before I do that, I don't really want a coefficient, that's this 3, with the x squared. So I need to try to rewrite this side so it just ends up being x squared. So again, keep your negative 1. It looks like I could divide a 3 out of both of those, right? 3 goes into both of those, so I'm going to rewrite this. I'm not really dividing a 3 out, I'm just rewriting it with the distributive property. So I have 3, and then x squared minus 2x. Again, if I would multiply this out, that would get me 3x squared minus 6x. So these are exactly the same. I just wrote it two different ways. Okay, next step, we're going to complete the square. So I come to the middle. Half of negative 2 is negative 1. Negative 1 squared is 1. Okay, so I want this to be right here. I want this to be a 1. Since there's nothing there, I'm just going to add a 1 in. Now remember, whatever I do to this side, I need to do to this side. So it wasn't really a 1 I was adding in. It was really 3 times 1, which is 3. So I really added in a 3. So I'm going to add 3 to this side. So I end up with 2 equals 3 parentheses. Okay, now this should be a perfect square. Hopefully you guys can recognize that. That was the point of this. That's why we're writing it in perfect square form. So it is x minus 1 squared. Remember, it was half of that. Okay, now this is almost in vertex form or graphing form. I'm going to subtract 2. Okay, so my final equation for graphing form or vertex form is y equals 3 times the quantity of x minus 1 squared minus 2. Okay, so from here, again, this is what you would write if I ask you for graphing form. I would write this. Now now for my vertex, I am going to use the graphing form. And remember, it's the opposite of this, so that would be 1, and then negative 2. And then if I want to find my y-intercept, I'm going to go back up to the original equation, which is up here, and I see it as plus 1. So my y-intercept is 0, 1. All right, so lastly, if I wanted to graph this, first thing I'm going to put on my graph is my vertex, which is 1, negative 2. So I'm going to come right here. There is my vertex. And then I'm going to put my y-intercept, which is 0, 1. All right, now, because I know where my vertex is, I know my line of symmetry is going to go through that vertex. So I'm just drawing a little dotted line here. All right, and because I see my line of symmetry, I know another point needs to be right across the line of symmetry, equal distance from that because it's a parabola. So I can add this point in. Okay, and then I can go ahead and connect my parabola. It's going to look something like this. It's going to be going up, which I already knew because it was positive. And again, it goes through my vertex here. Oops. The vertex that was right there, and my y-intercept and another point. Now I could go back and find the x-intercepts. I could go back to perfect square form, okay, and I could find those, but we're not going to on this problem. So hopefully that gave you a good understanding of how you write a quadratic in graphing form or vertex form if there is a coefficient in front of the x squared. So we are going to be practicing these tomorrow in class, so any questions that you have, come with those to class tomorrow.